I want to show you how to solve problems with two annuities. So there are a couple of really interesting problems we can do where there are two annuities involved. Unfortunately, most of your intro finance textbooks don't show these kinds of problems. So you should be familiar with an annuity, which is a finite stream of equal payments made at equal intervals. And there are lots of examples, but notably a mortgage, a car loan, or a pension would be examples of annuities. You're either paying a fixed amount every month on your mortgage, or you're receiving a fixed amount every month for your pension. So there are these situations where there are two annuities involved. For example, when you're saving an equal amount every year while you're working, and you want to know how much you can withdraw each year during retirement. Or we can do the opposite case. You want to be able to withdraw a certain amount in retirement, and then you want to know how much you need to save each year while you're working. So there are two annuities here: the amount you're saving and the amount you're going to withdraw. So for example, you want to save for n periods, and then you want to be able to withdraw the money from periods n+1 to n+t. So let's let PMT be the amount you save for n periods, and A be the amount you'll withdraw in periods n+1 to n+t. So to solve this type of problem, we need to be able to solve for the present value of an annuity and the future value of an annuity. There are two types of annuities based on when the cash flows begin. For an ordinary annuity, the first cash flow begins at the end of the period or one period from now. In an annuity due, the first cash flow is at the beginning of the period or starting immediately. So most problems are ordinary annuities, so we'll assume you begin saving in the next period, and the first withdrawal is made one period after you make your last deposit. So this is what the cash flow diagram looks like, right? You're going to save PMT for 40 periods or 20 periods, whatever it is, PMT in year 1, year 2, up to year n, and then you're going to withdraw A in year n+1, A in year n+2, all the way out to n+t. So here are the present value for an annuity formula and the future value for an annuity formula. So the present value for an annuity is the annuity times what's in the brackets here. And this is the present value of an annuity factor. 1 minus 1 plus r raised to the minus t power divided by r. So just note that the r is the interest rate, t is the number of periods, and the interest rate should be in decimal form. So if it's 7%, it should be 0.07. For the future value of an annuity, the term in the brackets is 1 plus r raised to the tth power minus 1 divided by r. So most standard financial textbooks will have present value of an annuity and future value of an annuity tables. Okay, it's not really necessary anymore because now financial calculators are quite prevalent, and you can even get a financial calculator app for your smartphone. So it's not really that necessary to use this formula. I'll show you how to use the formula, but I'll also use the financial calculator to show you how to do it. So two types of problems. Case 1, you know how much you'll save each period, and you want to find the amount you can withdraw in equal amounts. In this case, you know PMT and you want to find A. Case 2, you know how much you'd like to withdraw and want to know how much you need to save each period to accomplish this goal. So here you know A and you want to find PMT. So the trick to doing these is you start with the amount you know and you work towards the amount that is unknown. Case 1. let's find the future value of the amount you're saving. Step 2, find the annuity that allows you to withdraw the amount you've saved in step 1, because the amount saved comes before the money is withdrawn. It's a present value even though it's in year N. Okay, so in terms of present value and future value, it's when is that amount? Is it before or is it after? If it's before, it's a present value. If it's after, it's a future value. So example 1, you plan to save $10,000 per year for 40 years, the 40 years you're working. Okay, beginning next year, right? We want this to be an ordinary annuity. How much can you withdraw for the 30 years you're retired, beginning 1 year after you retire, if the interest rate is 8%? Let's find the future value of the amount you're investing in step 1, right? So we want to find what the $10,000 deposited in year 1 and in year 2 all the way out to year 40, what the value of that's going to be. So a common mistake I see is students forget to use the future value of the annuity formula, and they just multiply 10,000 times 40 and they get 400,000. And the reason you need to use the formula is that this is earning interest. This deposit in year 1 is going to earn 39 years worth of interest. This deposit in year 2 is going to earn 38 years worth of interest. So there's going to be a lot more than 400,000 in your bank account. So using the formula, we get 10,000 times that future value annuity factor, and we get 2,590,565. Okay, let's just use the financial calculator here. I previously solved it, but let's punch it in to make sure it works. Okay, the number of periods is 40. The interest rate is 8%. On the TI calculator, you put it in as a whole number. You don't put it in as 0.08. You put it in as 8. And you hit the I/Y key, interest rate per year. PMT is 10,000. And we want to compute the future value, and that's what we get, the 2,590,565, and a little bit of change. Okay, we'll just ignore the change. Now we know you'll have $2,590,565 in your account in year 40. How much can you withdraw beginning in year 41 for the 30 years you're retired? This amount comes before the withdrawals, so we use the present value of annuity formula and solve for the annuity A. Okay, so we know how much money you have here. We want to solve for A. So to do that, we simply divide both sides. Remember, the formula was PV equals A times this factor here. So to get this A by itself, just divide both sides, divide the PV by this amount here, and you get $230,113. Let's try it on the financial calculator. Okay. Clear this. Okay, you're going to be retired for 30 years. That's N. The interest rate is 8%. And we know that you have $2,590,565 is the PV, and we're going to compute the PMT, and we get $230,113. Case 2. Suppose you'd like to withdraw $250,000 per year for the 25 years you're retired. How much do you need to save each year for the 35 years you'll be working if the interest rate is 10%? So you're going to be begin saving in year 1 to year 35, and then be withdrawing funds in year 36. So again, here we know that $250 for this period here. And here is what you're going to be withdrawing. So step 1, find the present value in year 35 of the withdrawal. So it's the 250,000 times that present value annuity factor. Remember, we're finding a value before the money is being taken out, so it's a present value factor. And let's use the financial calculator. Second, clear TVM, right? Clear the workspace here. And we're going to put in what 25 is N. The interest rate is 10% in this case. And you're saving, or you want to withdraw 250,000. And we compute the present value. So we get 2,269,260. So now we know how much money you have in year 35. We want to figure out how much money you can take out for this, how much money you have to put into your account so it'll grow to this future value. Now this is in the future because it comes after your deposits. So we take that amount, and just like we did before, we divide it by the future value annuity factor. So let me just make sure that works. Again, clear your workspace with second, clear TVM. And N is you're working 35 years. The interest rate is 10%. And the future values 2,269,260, and we compute the PMT, and you have to save $8,373 each year so that you'll be able to take out the 250,000 during the years you're working. During the years you're retired. So just a summary here, okay? If you know PMT and you want to solve for A, find the future value of the PMT and then use the present value of the annuity formula to solve for A. For case 2, if you know A and you want to solve for PMT, find the present value of A and then use the future value of an annuity formula to solve for PMT. So, these are much more realistic questions or problems than, you put all your money in the day you start working. And I hope you found this useful, and thanks for watching.